Okay, 11.1, matrices and systems of linear equations. So a matrix is simply a two-dimensional collection of numbers. Suppose we have the following breakdown of grade and gender at John Cooper. So we have 52 female freshmen, 48 sophomore females, 60 junior females, and 46 senior females, and then the same with males, 58 freshmen, 61 sophomores, 41 juniors, and 50 seniors. We could put this in a matrix labeled right here. So A equals all of that. So all those entries have just been moved to all of these places for our matrix. We'll develop some matrix operations to help us use these arrays of numbers to work with information like this more efficiently. So a matrix, an m by n matrix, is a rectangular array of numbers with m rows and n columns. So that's a couple of things. So it's that x, you say by, so it's like an m by n or a 2 by 3 or whatever. Your rows are horizontal lines and your columns are vertical lines like the column on a building. You label your matrix or the dimensions of the matrix as row by column. So you'll have the number of rows by the number of columns. All the entries have little subscripts, ij or 1, 1, 1, 2. So like this is A1, 1. This is A1, 2. So first row, second column. First row, third column. Third row, second column. So the first number is the row, the second number is the columns. So with our example from above, what is the dimension of matrix A? So it has 2 rows, and 1, 2, 3, 4 columns. So it's a 2 by 4 matrix. And then it says find entry A23 and interpret this value. So that means, let me erase this stuff. Means I'm on row A, or on matrix A, row 2, entry 3. So this is A23. So A23 equals 41. And what does that mean? So if we look at our information, this is freshman, sophomore, junior, senior, and then this is female, male. So that means I have 41 junior males. At John Cooper. And then the next thing, sorry, this is going to open the calculator. It says to input this matrix into your calculator, then type 2a and display the results. What does it look like? The operation of multiplying matrices by an integer does to the matrix. This is called scalar multiplication with matrices. Let's see if we're ready yet. Still thinking about it. So we have our calculator, add a calculator, and we want to make a matrix. So menu, number 7 is matrix, create a matrix, and we want it to be a 2, that's good, by 4 actually. And then it gives you the little spots for the matrix. So I'll type it in, 52, if you hit tab it'll go in between them easily, 48, 60, 46, 58, 61, 41, 50. And I want to store this in so I don't have to type it in every time. So I'm going to hit Control and then var, that's right up here above the 9, and that gives you the little arrow and you can tell it where you want it to store. I want it to be A. So I'm going to store that as A, hit enter. Now that knows that that's matrix A, and now I can do 2A. So 2 times A, notice the A is now bold and not italicized anymore, so it knows what I'm talking about. Hit enter, and we get our new matrix. So if you look at it, it looks like it just took every entry and multiplied them by 2, right? 52 times 2 is 104, 48 times 2 is 96, 60 times 2 is 120, so on and so forth. So, oops, that's not what we're on. There. So when you're multiplying a number times a matrix, a scalar multiplication, you're just going to multiply each entry by 2. Or 3 or 4 or whatever it ends up, you end up multiplying by. All right, one useful application of matrices is to use them to solve systems of linear equations. So first you can write the system of equations as a matrix. You just take all the coefficients. So like the 3 is right here, the -2 is right here, the 1 is right here, the 5 is right here. And you do that for all of them. That's called an augmented matrix. Notice that a missing variable, like we didn't have a y right here, it's going to just be a 0 entry in the augmented matrix. So first example, find the augmented matrix. So our matrices have brackets, 6, -2, -1, 4, 1. We don't have a y, so that's 0, 3, 1. And then we need these to be like this to be over here. So 7y plus z equals 5. So 0, 7, 1, 5. That's our augmented matrix. That's the word for that. When you're working with equations in a system, you can perform certain mathematical operations on equations to produce equivalent equations. So when we were solving systems of equations last class, you could do different things. You can multiply it by one thing to do elimination. You can add them together. Those are called elementary row operations. So you can add a multiple of one row to another, multiply a row by a non-zero constant, or you can switch two rows. When we perform elementary row operations on a matrix, we change the matrix. However, the linear system that the augmented matrix represents is still equivalent to the original system. We call matrices that are different but represent equivalent linear systems row equivalent matrices. So here's the notation we use, and I used that when I did the video for the systems of equations, so it shouldn't be new looking to you. So row 1, row 2, row 3, some number times that. That's what all of that means. So the next page, sorry, I'm kind of going through this fast. Recall that a linear systems of equations is very easy to solve when it's in triangular form. So on the left side, you have a system of equations. On the right side, it's in triangular form, and it's much easier to solve. So our method for solving that is called Gaussian elimination. It's a technique for solving a system of linear equations. So we can do that with matrices. Instead of having all these variables in here, we can put these numbers into a matrix and try to get it down to where we just have some number equals, like some number equals some number, and that's going to stand for z, because this is like your x row, your y row, your z row, your equals row. So same idea here. If we can get it down to the z equals, have zeros here, so a 0 and a 0, and then you get z equals, then you can plug it in, and then you can plug it in, right, and do back substitution. Whoops, sorry. There we go. So that's our goal when we're doing this. Okay, I'm going to stop this video, upload it, and put a new one so I have time to do this next problem.